Okay, so we are doing the third and actually final method for solving systems of equations, and that's elimination. Notice there are two here, 11.3, 11.4. We're going to do 11.3 for the next two videos, 11.4 for the video after that. One of them is, your book describes them a little differently. We're going to make one of them word problems and one of them not word problems. So we're going to start without word problems, obviously. So today in the next video, we're working on pages 68 and 69 in your notebook. So go ahead and label 68 and 69 11.3, solving linear systems by elimination. Okay, so I'm going to turn to 68 and 69. We will be doing 68 today, 69 in the next video. So 11.3, solving linear systems of equations by elimination. And I'm going to go ahead and label 69 as well. Okay. This is a foldable. It is attached to this video. It'll actually have the first and second foldables in there, the one for today, the one for the next video as well, for the part 2 video. Okay, so take it, fold it in half. You are only working on the one, like I said, it's like the first 2 pages. I would like to go ahead and apologize. They did not number. These are not numbered, which kind of drives me crazy. So this is number 1, number 2, number 3, 4, 5, and 6. And then the other questions are going to be in the next video, part 2. Okay. All right. Solving systems of equations by elimination literally means what it sounds like. I'm going to eliminate one of the variables. In order to eliminate, they have to have a plus and a minus. It doesn't matter which one's plus, which one's minus, and the same number. So we're actually going to look at these. We're going to start by looking at this x right here. Let's look at the x and all the x. These two, the number in front, one is 2, one is 3. I cannot eliminate those. They're not the same. Why's? One is 5, one is 5. One is positive, one is negative. I can eliminate those. I'm going to take and box in the ones I can eliminate. After I do that, I'm going to add straight down. 2x plus 3x is 5x. 5y plus negative 5y is 0y. So I do not bring it down. Equals negative 24 plus 14 is negative 10. The goal is to get one of them gone, eliminated. So I should only have one variable. Now I'm going to divide by 5. So x equals negative 2. Once I have solved for one of the variables, I'm going to take this and plug it back into one of these equations. It does not matter which. I'm going to use the top one in this situation, but it didn't matter. I'm just going to rewrite that one down here. And then I'm going to plug in for x. So 2 times negative 2 plus 5y equals negative 24. After I plug in x, I'm going to solve it for y. So that's negative 4 plus 5y equals negative 24. Add 4. So 5y equals negative 20. Divide by 5. So y equals negative 4. And last, I'm going to write the solution in an ordered pair. Negative 2, negative 4. That is how I solve by elimination. I look for the same number in front of the variable. Then I look for the opposite signs. Then I add straight down. Number 2. X. 3x and x, not the same. We will have some tomorrow that aren't the same. We'll have to talk about what to do with that. The next one. 2y and 2y. They are the same. However, they are not one positive, one negative. In order to change that, I'm going to have to multiply one of them by a negative 1 to fix it. However, I have to multiply every single thing in this line by a negative 1. Negative 1 times x is negative 1x. Negative 1 times 2y is negative 2y. And negative 1 times 14 is negative 14. It did not matter which one I multiplied by. I'm then going to rewrite this one because I need them to be lined up to eliminate. I didn't change that one. Now I'm going to box in the ones I will be able to eliminate and add straight down. 3x plus negative 1x is 2x. 2y plus negative 2y, the y's will go away, eliminate, equals 5 plus negative 14 is negative, I think 9, but I better check. Yes, negative 9. Divide by 2. And x equals negative 9 halves. Yes, leave it as a fraction, it won't kill you. Then take a second and plug that back in. Now, we're going to plug it back in. Doesn't matter which one. I'm going to plug it back into this one. So x plus 2y equals 14. You actually have 3 options now. You have this one, or the one you changed. It does not matter which one you plug it into. Negative 9 over 2 plus 2y equals 14. Don't freak out about the fraction. Add 9 over 2. If you don't know how to add the fractions, your calculator will do it for you. 14 plus alpha y equals, enter, 9 over 2 gives you 37 over 2. Still fine. 2y equals 37 over 2. And then you're going to divide by 2. Y equals, your calculator will do that too. You got 37, just press divided by 2. You get 37 divided by 4. Now, I did get up in the middle of this video because I didn't think it should have gotten a fraction, but I accidentally, this should have been 1 instead of 14, but it's okay. We can have a fraction. It's not going to hurt us. If you would rather have it in a decimal, which is fine, you would have gotten negative 4.5 comma 9.25. That is fine as well. Just because you get a fraction or decimal does not mean it's wrong, so don't think it does. All right, let's open this up and do number 3. Actually, I'd pause the video. You need to start trying things on your own. All right, number 3. Are the 4s the same? Yes. But they're not one positive, one negative, so let's check the y's. Are they both 1s in front? Yes, but they're not both one positive, one negative. So we're going to have to change one no matter what, which means we're going to have to multiply one of them by -1. Doesn't matter which. I just like to do the bottom one. But it doesn't matter. You could do the top, and you'll still get the same answer, just not the same work. You do have to write the first one back down. Don't try to do this without doing that. That gets on my last nerve. I don't have many left. And then add straight down. These look like they'll cancel. 4x minus 4x, yep. Oh wait, negative x plus y will also, negative y plus y will also cancel. You don't have anything left over here. 3 plus 2 is 5. Does 0 really equal 5? No solution. If both variables eliminate, you are going to either have no solution or infinite solutions. If both variables eliminate. Number 4. Let's see what we got. Do we have a 1 and a 1? Yes. Do we have one positive, one negative? Yes. So we don't have to do anything. We just have to add. These look like these are the ones that will cancel out. Okay, then let's look at this one. Negative 6y plus 6y. Ooh, those are going to cancel out too. We don't have anything left. 7 minus 7 is 0. Does 0 really equal 0? Yes. Since both variables were eliminated, I either have no solution or infinite solutions. This one is infinite solutions because the statement is true. 0 does really equal 0. Okay. Go ahead and try 5 and 6. They are not special. Go ahead and try them. Remember, you can pause the video whenever you need to. Number 5. Are these two the same number? Yes. Is one positive, one negative? No. Let's move on and see about this one. Same number? Yes. One positive, one negative? Yes. So all I have to do is add straight down because these are going to cross out. Negative 7x minus 7x, or plus a negative 7x, is negative 14x. 5y minus 5y, those cancel or eliminate. They're not really canceling. It becomes 0y. We don't write that down. 15 plus negative 15 is 0. Something people like to do in this situation is the second they see it's equal 0, they start writing no solution because 14 doesn't equal 0. That's not what this says. Both x and y did not eliminate. That means we have to keep going. It's fine that x is equal to 0. That's still a number. Don't think you need to stop because that happened. Then we're going to plug it in. So let's use negative 7x plus 5y equals 15. Remember, it doesn't matter which one you use. Plug in 0, so it's negative 7 times 0 plus 5y equals 15. Negative 7 times 0 is 0, which I really didn't even have to write the 0. It's just 5y equals 15. And divide by 5. y equals 3. So my coordinate is 0, 3. Okay, pause the video and try number 6. Okay, x's, are they the same number? Yes, but they're not opposite signs, so let's look at y's. Same number? No. So let's go back. We're going to have to change, multiply by -1 on one of these. -3x plus 5y equals -16. I'll rewrite this one. Don't try to do this without rewriting it, or I'm going to not be very happy. I'll make you redo it. Okay, these are the ones that are going to eliminate. 6y plus 5y is 11y. Why? Because that's what it adds to be. 27 minus 16 is 11. Cool. 5 by 11. Y equals 1. And plug it back in. Notice this time I solved for y. So I make sure I plug it into y. And I'm going to use this first one up here because it doesn't have any negatives. 3x plus 6y equals 27. 3x plus 6 times 1, don't forget it's y this time, equals 27. 3x plus 6 equals 27. Let me move that so you can see it. Subtract 6. 3x equals 21. Divide by 3. X equals 7. Make sure you write it down correctly too. It's x, then y. This is how you work problems with elimination. We're going to glue that in on page 68. Then you're going to work on the assignment that's on Google Classroom. Here's the title in case you didn't get it at the beginning. 69 has the same title. We will do 69 in part 2. There you go. So go ahead and get started on the assignment.